Hello and welcome to chapter 6. This is all about disk partitions, including swap partitions. Let's dive into the intro. And that's enough for the intro. So let's go back. Well, let's dive into the terminal right now. Okay, I'm going to work on my second machine, which is also called Rocky 2 for the most part. Okay, so that's where we're going to spend most of our time in this chapter. And we're going to discuss all about disks and partitions. Okay, that's it's going to be the main theme here. It's all about disks and partitions. We're going to discuss disks, we're going to discuss partitions, swap partitions, MBRs and GPTs, okay, global partition tables, and also MBR, the master boot record partitions. So we're not going to dive into all the nitty and gritty details. We're just going to discuss the main part, the main configuration things that this course will cover, or covers, and this will also get you up and running for the exam if that's what you fancy right now, and I believe many of you guys do. So that's kind of what we're going to do here. It's prepare you guys to have success in your exams. Okay, so let's start with Rocky 2. Let me just get myself into some root access here. Just double checking everything's fine. And yeah, so let's start with some tools that help you check the current state about disks and partitions. So we're going to see some terminal commands, some executables, of course, that will help us identify our current state about disks and partitions. I'm going to show you three: the lsblk commands, the blkid commands, and also we will get the proc partitions file. Okay. So this is going to more commands will follow, but let's discuss these three first. Okay. So this order is fine. So lsblk. So this is going to show us how our hard drives, how many hard drives you have. When I say hard drives, I say hard drives. I can say it's SSDs and NVMEs, all the storage types that this specific server can see. So here I have SR0. SR0, it's all about optical drives like CD-ROMs and DVD-ROMs when that's something you are using. But if you're using a physical one or a virtual one from the cloud, SR0, it's usually something about CD-ROMs or DVD-ROMs, okay? Also, we'll have here the NVMe. So NVMe, it's the first 1 second. Let me just get a couple things ready. This, then that. Okay. So NVMe's are the most current, quote-unquote, current storage types. It's the NVMe drives. And you can see here different things like SR0 are optical. Then you can also see NVMe, of course. NVMe drives. And it will show as NVMe with the number. You can also see SDXs. SDXs, it references SATA and SCSI. Okay. You also probably see, some of you will see ADD0. It references IDE drives. IDE drives it's something really dated and old, but you might still see it. So SR0s are opticals, NVMEs are NVMEs, SDs are SATA or SCSI. I'm sorry, this is not correct. This is correct. And this is correct. Okay. So SDA, SDB, SDC, etc. Let me put it here for reference. So SDA, SDC, SDD, etc. are going to be your SATA or SCSI drives. And these are going to be HDA, HDB, HDC, etc. are going to be your IDE drives. Okay. Probably most of you guys will not see IDEs if you have not seen them before, unless you have something specific to work with. So SATA or SCSI or SCSI drives. Okay. So as you can see here, you'll usually see NVMX and the number, or SDA, SDC, SDD. If by some accident or by some situation you reach the SDZ and you need another drive, you will see the SDAA, SDBB, SDCC, and so on and so forth. And also this applies to your SATA. Okay, and not SATA. I'm sorry. All the HDs also. So HDB. If you reach HDZ, you'll see the HDAA, HDBB, and so on and so forth. Okay, so you have a big range of drive assignment assignments in a way that you can have. So you can be rest assured that you probably in a real situation, you most likely won't run across some limitations or problems regarding identifying your storage devices. So you should be A-OK 99.9% of the time. Okay. So this is what lsblk gives us. I can also do lsblk minus fs. Fs means file system. It's going to show us some other information, like for example the ID of the file system. Okay, you can also see what was the file system used to format those drives. I know that in Linux we don't say formatting, we say create a file system, but tomato tomato, potato potato, there is no big of a difference. So when you format or create a file system, this is going to show how you did it. XFS nowadays XFS is kind of the most common one, but you probably see others like ext4, ext3, ext1, or other more specific file systems depending on the use case. But XFX, it's kind of the standard one, if you want to call it standard. It's kind of if you are going to format a drive or partition using Linux file systems, XFS is kind of the de facto default, unless you need something more specific. Then you can also do the cat proc partitions. I have talked about the proc file system in this course beforehand, so check the other videos to get more details. So here the partitions, we have the same, not the same, but a big approximation of information that you get from the other commands. And also we also have here the DM0. DM0 is all about logical volume manager, and now we'll discuss logical volume manager on chapter 7. The next one, I think the next one is 7. And I will tell you more details about that when we reach chapter 7. So ignore this for now, and let's focus on the lsblk command with or without the fs option. You can also use the blkid. The blkid, it's kind of a cousin from lsblk. It's going to show you similar information with a different output. So there are no better, or there is no good or bad. So just take your pick on the command you prefer, or just use the command you remember. Okay, there is no right or wrong here. Just use the one you prefer, or use the one you actually wish to use at your own leisure. Okay, so let's go back to lsblk and let's analyze this. So here I can see that I have the optical drive. So let's let this one stay as it is. NVMe, it's our first drive, and I can see that the NVMe has two partitions, and the partition I will explain a little bit better in a second. But the partition is kind of a division. You have the main drive with an X amount of space, and the partition, it's just, you can divide that in different slices. Then you can use each slice for your own effective use. So I have here two partitions. Here you can see I have the device name NVMe00. Okay. Then I have the partition 1 and have the partition 2. Partition 1, it's 1 GB big. Partition 2, it's 19 GB big. Okay. And as you can see here, I have this partition. It's kind of a special one because it's divided into LVMs, and LVMs I'll discuss on the next chapter. Like and subscribe to get on top of that. Okay. But in a nutshell, we have two partitions, P1 and P2. This partition is 1 GB big. This one is 19 GB big. The usefulness of this partition is to boot the system, and the usefulness of this partition is to give space to the logical volume manager subsystem. So let's leave the logical volume manager subsystem for the next chapter. So let's focus on normal partitions, okay? And usually normal partitions are MBR partitions or GPT partitions, okay? So MBR, it's the older one, the older method. It does not mean that it's useless, it's just older. The global partition, the GOID partition table or GPT, it's the most recent one. So I'm not saying that MBR is to be discarded, not at all. You can use one or the other, but MBR, it's a little bit more dated, which means that the partition sizing, it's a little bit smaller and with some limitations. GPT, it's the most recent one with less limitations. You'll understand why in a couple of minutes. The differences, they are pretty simple to understand. Then if I go back here, I have two storage devices, NVMe N2 and N3. So this is N1, this is N2, this is N3. And you can see that N2 is 22 GB big in my case. N3 is 23 GB big. This will vary depending on your case. These are my NVMEs, my secondary NVMEs. So this is my primary NVMe. This is one of my secondary NVMEs. This is the other secondary NVMe. This is my computer, my server. It does not mean that yours is going to be the same thing. Okay. So this is my situation. Your situation will be different. That's why you need to use these commands to explore your use case, so you can find out your specific server, what is its current situation. My server has one device, one storage device, second storage device, and third storage device. This is the first one, second one, third one. They happen to be all NVMEs, but it doesn't have to be like that. You can have mix and match between NVMEs, SATAs, SCSIs, whatever the case. It's all fine. Just need to be aware of its limitations and correct features. This major and minor, do not give it much importance. It's not all that's relevant for this discussion right now. These are just kernel references. Okay, each one will have its own kernel reference, which is normal. Don't dive too much into this. Don't try to understand too much of this. It's fine. You don't need it for now. Just focus on this: the name and the sizing and the type. Okay, so this is a disk, NVMe is 22 gigabytes big, and it's a disk. No surprises here. It's a standard disk. We have the N2, which is 23 gigabytes big and is also a standard disk. So I can also see that apparently, and this is most accurate as possible. This is the storage device that has no partitions and it doesn't have mount points. I will explain what a mount point is in a few minutes. But since it has no mount points, it means that most likely it's not being used for nothing. It has no use. So the mount point means this has no use, no current use. So it's a physical device that exists, but it's being used for nothing. Okay, it just exists. So that's why we're going to use this one. We're going to focus on this one here. So I'm going to get this one, and this is going to be partitioned into MBR Partitions, master boot record. Okay, so I'm going to get this disk, and I'm going to partition this disk into master boot record partitions. Okay, but before you do that, let me explain a few concepts. So let's get some space on my notebook. Give me a second. Then you can just jump into here, get my pen, and I can explain. So we're going to discuss here the MBR, the master boot record. Okay, and MBR has a few limitations, and I'm going to explain to you guys what those limitations are. Okay. So in MBR we have 3 partition types, and the naming scheme can be a little bit controversial, just because it depends on who's explaining those names. There may be some differences, but play along with me and you'll understand. So one of those types, it's called primary partitions. Primary partitions can be called like the main type of partition we have here, and the primary partitions are used typically to boot the system. Okay, this is in generic terms. In standard terms, they are used to boot the system. Okay, then you have extended partitions. Extended partitions are used to house or to keep, to cocoon what's called the logical partitions. Okay, so what's happening here? So the extended partition only exists so you can house the logical partitions. So it's kind of an enclosure for a second partition type, which is called the logical partitions. So if you create an extended partition to house the logical ones, you cannot put data directly onto the extended ones. Okay, you cannot put data directly onto the extended ones. Okay, you will just create extended to house the logicals. You'll understand this better in a few minutes, I assure you. There are more limitations. You can only have 4 partitions on one disk, and what counts as a partition are primaries and extendeds. But you can only have 4 of those types, and of these 4, only one can be the extended type. So in simple terms, let's say you have 4 partitions. 4 primary partitions. Okay, so you have 4 primary partitions. You are done. More than 4 you cannot create. Then you have 3 primary and 1 extended. This gives us the magical number 4. You have 4 partitions now. Okay, you have run out of options. but only one can be extended. You cannot have two extended partitions. So the magical number is always 4, and of those 4, only one can be extended. So if you create 3 primary partitions and one extended, okay, if you create 3 primary partitions and one extended, you have reached the number 4. And of those 4, one is already extended, okay? Now you can put inside the extended some logical ones, correct? If you have 2 primary partitions and one extended, okay, and one extended, you have 3 partitions. You can still create one more if it's not extended, if it is primary, and if you have enough free space. So magical number is 4, one of those 4 can only be one extended. Do you get the idea? So can have maximum 4 partitions and only one can be extended. So for example, if I have here a device, a storage device, if I have 1 primary, 2 primaries, 3 primaries, if I am careful, I can use the remainder of the space for an extended partition. Then I can just create logical partitions within it. And the most common number is that you can have 16 logical partitions for most situations. So you can actually kind of see that the creation of the extended partition and the possibility of creating logical partitions within it, it was kind of a way to get around the number 4 limitation. Okay? But if you do something like this, primary, 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 and this is free space, you are SOL. You are dead in the water, because you cannot create a 5th partition. This is free space that you cannot allocate unless you delete this partition and use it like this, or create an extended with logical ones within it. Okay? So never forget, you have the limit is 4, the magic number is 4, and of those 4, only one can be extended. Okay? So the magic number is 4, and only one of those 4 can be extended. Okay? If you have 3 partitions, you can create more partitions. If you can create a 4th primary, an extended, etc. if you have free space. So 4 is a magic number, and of those 4, only one can be extended, and the extended partition exists so you can house logical ones. Typically, maximum of 16 logicals. What is GPT? Well, GPT is similar. I can jump the gun a little bit. If you opt for GPT, you don't have primaries, you don't have logicals, you don't have extendeds. They are just considered partitions. You don't have different partition types. They are all just partitions. And you can have a maximum of 128 partitions. That's GPT for you. So 128 partitions, they are just partitions. They're not considered primary, extended, or logical. They just exist. You can have the maximum of 128, which is a quite nice number. And also the partition size can be much, much larger. You don't have to remember how big can it be, because the tools will guide you. You don't have to be too much worried about, well, you should always worry a little bit, sorry. But all of these limits, all of these ceilings, the number 4 partitions, only one extended, etc., it's quite impossible to go overboard with this. You are always, if you use the correct tools, and I hope you do, you're always always oriented to stick within the limits. It's kind of hard using those tools to damage something or go over the limits. Of course, if you want very much, you can go over the limits if you really want to. But if you use the correct tools, which we will use here, the tools will just let you know that the limits were reached and you cannot go any further than that. So let's go to MBR first. And then my tool of election to deal with MBR is the fdisk tool. Okay. So I do fdisk, then I do /dev device. I hope you remember at this point what is a device folder. If you don't, go back to my other videos. Like and subscribe. And I can then specify the device to manage. Okay. And as simple as that. Now I am editing the partition table of this storage device. Okay. I'm not going to bore you too much with the fdisk tool. This video is already long enough, so I don't want to go too much overboard, even though I really like to go overboard, but I will just control myself. And I'm going to use our fdisk tool to create a couple of partitions. Let's create a primary partition. So let's create a primary partition on this device. I like to start with the P option. Well, we can always type the H. H will just I'm sorry, not HM. Now it's M. It used to be H. It's here. If you type M in this case, you'll see all the nitty and gritty details. But I like to start with the P option. This will print, and by printing, I just see what I already know, which is an empty drive. How big it is? It was here in lsblk. You are actually just seeing that it's a 22 gigabyte disk, so we already knew that from the get-go. So let's print. Now I want to create a new partition. I want to create a new primary partition. I use the N option, N for new. Okay. As you can see, I'm always guided to the good end. Okay. I want a primary partition. Nowadays, you can boot from any partition, but it's highly recommended for other reasons. I will not dive into that right now, but it's highly recommended if you are doing a boot partition to be primary, if you are using MBR. Okay. As you know, GPT, there are no different partition types. They are just partitions, but primary partition is the recommended partition type to boot the system from. So we will create a primary partition. He will ask you for the partition number 124. If I hit enter, he's going to use the default option, which is partition number 1, and I will. And now he asks me for the sectors. Let me give you an idea how I interpret sectors. This is going to make many people angry because this is not very accurate, but honestly I don't care. So imagine a storage device like sliced bread. Okay, we have sliced bread. Everybody loves sliced bread. So what is a sector? A sector is a slice. So if you imagine this as your hard drive or storage device, whatever the case, a sector is a slice. So let's think about this in absolute terms. So what is the smallest bread piece you can eat from this sliced bread? What is the smallest bread piece? Yeah, I know you can cut the slice in half. I know that, but let's think through this in absolute terms. So the smallest piece of bread you can eat, it's a slice. So that's what the sector represents. A sector, it's a slice of the storage device. You cannot allocate less than the slice. And that's what the sector is. So fdisk is asking me where is going to start the partition, in which slice sector. So he's suggesting you to start, this is just an imaginary thing, right? He's telling you, okay, the partition should start here. Okay? So why is he reserving 2 slices for something? He's reserving 2 slices for the MBR itself, okay? MBR requires some space to get its data written down to. So this is fdisk just reserving some space for the MBR. That's why he's saying, I recommend you to start on slice 248, okay? That's why he's not recommending you to start on slice 0, and you cannot do that. You cannot start on slice 0 in this case because he needs the space to make MBR work, okay? So you cannot really start on slice 0 because you cannot start on slice 0 because it was technically impossible. The disk would just be useless. So we start here. If you look carefully, you can start further down the line. If you wanted, you could start here, here, or here, whatever the case. It will depend on the situation. In this case, I just want to create a normal standard partition, so I will start on where he suggests, and he suggests to start here on sector 2048, and that's fine. Which means that if I have here my drive, this is more or less going to be the MBR. My first partition will start here, and I will hit enter to accept the suggestion. And now he's going to ask me how big this partition is. So I can say how big by saying how many slices, sectors, or using more human readable names like gigabyte, petabyte, terabyte, and all of that stuff. Okay. So let's say I want a partition 1 gigabyte big. So I just type plus 1G, And now I have a 1 GB big partition. So if I go back to my drawing, we started at sector 2048. I said 1 GB big partition, and the fdisk application just decided how many sectors he would need to give me a 1 GB big partition. So I said 1 GB, and he said, okay, this is our start, this is our end, and he did the math for me. When I said 1 GB, I could also set the sectors, so I can be very precise where the partition starts and where the partition ends. Sometimes it's needed, but for now, that's not important for us. I just want a 1 GB big partition, and the partition type needs to be primary, and that's what we did. So primary partition, I accepted the number 1. I accepted to start when he suggested it, and I said I want a 1 GB partition big, and he did the math and decided how many sectors we would need. Pretty simple. To confirm, I like to use the P option to print. Now, nothing happened. This is much like VI. I have not saved yet, right? So, which means that since I did not save, nothing happens. If I hit Ctrl+C now, or the Q option to quit, nothing was saved. It's fine, but I want to save, so I will use the W option to save. This is no news, good news. This is if there was something wrong, I would just know it immediately. So I will just go back to my lsblk. New partition is there. I come back to my proc partitions, and you'll just see the new partition being there, and all is good. So we have created a new partition. Okay, I will do this twice so you can see, but let's go down the line. So we have created the partition. Now we need to make a file system. Some people call it a format, which is fine, but in Linux you call it, let's create the file system. That's basically the same thing. I don't care what you say. So to create a file system, you use the mkfs, so it's called the make file system. This is one way to do it. Then you can do -t to say that the file system type, and you will specify the partition you just created. This is what we get from noon. These are good news. Don't try to interpret all of this. It doesn't really matter right now. If there was a problem, you will just know it in your face. This is all good. Okay. If you want it, there are also some shortcuts like the .xfs. This will format in XFS, ext4, and others. So if I hit tab, you'll see there are some shorthand shortcuts to format in a specific file system. Or just type -t, and you are good to go, and you're off to the races. If you do this, you can specify which one. It's exactly the same thing. If I go to lsblk-fs, you see our partition was formatted using XFS and looks A-OK. blkid also shows us the same thing, so we are A-OK. So we have created the file system. We have created the primary partition, and we have created the file system. Fine. In order to use this new partition, you need to create a mount point. A mount point, it's like in Windows, you have the drive letters. Okay, in Windows you have drive letters, here you have mount points. The short version is a mount point. It's a folder that maps to the device. Every time you read or write from that folder, you are reading or writing from that device. It's like a drive letter on Windows. Okay, so if I go back here, I have a 1 GB primary partition created successfully, and we are ready to use it. It's formatted with XFS. Okay, now we will mount it. To mount it, we need to create a folder first, and usually you have the mkdir, and usually you have the mnt. You have a folder called mnt, which means mount. You can use this folder or any other folder. Only root can do this, of course, but I'm going to call it partition 1 just to make things a little bit simpler. And now I just type mount. You can mount on any folder, but I highly recommend that at this stage of your probably less experienced, create a folder just for that on the mnt. It's you will be mostly safe. So /dev, the partition you just created, the file system, and the folder. And now if I go back to lsblk, there we go. This partition now is mounted there, which means that everything I read or write from there, it's from this partition. Okay, so let's say this was your USB drive, your USB pen drive. It will be the same process. Just make sure that you're mounting on an unmounted mount point. So mount it on a folder that is not listed here, because if you mount a partition twice on the same folder, problems may occur. So make sure you mount on a folder that is not listed here. Don't mount things twice. It can be really bad, really fast. We are done. But be aware that this is not going to survive the reboot. If you reboot the server now, the mount action will not occur automatically. Okay? The folder is there, the partition is there with all its data within. So the data is there and safe, the folder exists. This connection between the partition and the folder, it's not existent. Data is safe there, but the folder will be just empty without any connection to the partition. So if you want to make this connection at boot, let me just copy this and you will understand why I'm copying this. You need to edit a file called etc fstab, because this file is the one is going to be executed in a way in the next boot. So keep what is already there, just keep it there. Just get some space for you guys. I'm going to do some cosmetics. So my custom partitions. This is just optional, but I like to do it. Partitions. This is just cosmetic, but I find it comfortable for me. Okay, then I will just put my custom ones. And this is really easy. You just need to put your device and the folder. Or you can also use the ID. It's fine. Let me show you. If you do lsblk -fs, you can also actually use this ID. Okay. There are some use cases for the ID, but for now I will not explain why the ID can be useful. Just understand that you can use it. Okay. Next, I can just look here and use this as a reference. So XFS is how I formatted it. We will use the default options. These options are used for performance options, security options, quotas, but use the default ones. And these numbers nowadays, 00 or 101, it's plenty enough and you are good to go. So the device or ID, the folder, the file system we use to format, special options if you want any, or just type defaults and you're good to go. 00 or 101-ish, you are perfectly fine. So we'll save and quit. Now you can do mount -a. What this will do is it's going to read this file and apply it. If there are any errors, you will get notified if there are errors. If there are no errors, spit it out. You are good to go and it's good. There are no problems, which means that you have 99.9% of a good chance of rebooting the server successfully without any issues. Cool? Cool. So let's create a new one. That's not the one I want this. So let's create 1 GB primary partition with XFS. Okay? I mean, why not? So we just go back where we were. To the fdisk. Okay, print. It's giving you a warning that says that this disk is currently in use, which is true. It is in use. We just gave it use. So new partition, primary partition. I can type P, or I can just I can type the P letter or just hit enter. It's the same thing. Number 2, I'll accept the suggestion, which is he's going to say, okay, this partition will start just after the first one right here, and I'm happy with that. I'm fine with that. So I will accept it. The size again +1G, 1 GB, print. There it is. We save. Now we format mkfs. Just look for the mkfs command we used before. I don't have it here, do I? I don't have it here. Anyways, mkfs -t xfs, and the second partition, all good. Don't worry, it's hard to format a partition twice. If you try to format a partition twice, you'll get a warning. So cool. Now you have created a partition, we have formatted the partition. Now we can just create a folder. And now we can just go to the fstab directly. I will just copy paste this line and just be lazy and just change a couple of the specific things. We save. lsblk is not mounted, mount -A, ignore that, and it's mounted. So, and so on and so forth. Pretty okay. So let's just create a special, now let's create a special partition type. It's called the swap partition. The swap partition, it's not mandatory to create. You can live without the swap partition just fine. But it can be handy when to manage crashing systems. It can be handy on laptops for hibernating. So even though it's not mandatory, in some situations it can be handy. And the good news is you can create a swap partition. You can create a swap partition on demand when you need it, and remove if you don't need it. So it doesn't have to be always there. You can also create a swap file if you don't want or cannot create a swap partition. There is an option to create a swap file instead of a swap partition. Let's say it's impossible to create a partition, you don't have enough hard drives or enough partition types, whatever. It's impossible to create a swap partition, but you want to create a swap file. You can create a swap file. I will not show you how to create a swap file on this chapter, but I am going to make a video outside of the scope of what the RH134, how to create a swap file. Like and subscribe to get notified of that. Okay, so let's create a swap partition. Let's first see if you have any. So we can use the free command. As you can see, we already have a swap partition. That's fine. Let's create a new one. Since it's a swap partition, it's like a partition like any other. You just go to the fdisk, print, new partition. I mean, it can be, I can create a primary partition. That's fine. Let's say 3, it's fine. You can start here. Let's make it 1 GB big 2. Print, fine. Now, before we continue, you should change the type from Linux to swap. How? T, set the partition number 3, and type, you can do capital L to get the list, and the swap is 82. Print, there you go. So type, partition number, and type 82. And this is a swap partition now. Not yet, it's not finished, but we are doing well. So let's save. We are fine again. Now, what is the sequence? Create a partition, format, and mount, right? So let's format a partition with the command mkswap. And we will create like this. There we go. It's done. Now you go to the fstab. Okay, let me just get this reference here. Oh, let me just copy this. I need this reference. I will go to the fstab again. Now let me show you something. It's not yet seen as space, as swap space. It's created and it's formatted, but it's not exposed to the kernel as swap space yet. So let's go to the fstab via etc fstab. Let's create a new section to be organized. My custom swaps. Why not? We go here like this. We paste. Oh, damn it. Let me save and quit. Let me get this information back. Go back there and just paste this. Now since we already have a swap, you can just cheat a little bit. They use none swap, but you can also do swap defaults 00. Yeah, I'm lazy. Copy paste. It's king. If you are careful, of course. So let's just make things a little bit visually more appealing. You don't have to do that. You just can. So yeah, I mean, it was better beforehand. It's fine. So let's save and quit. Now you don't do mount -A. You do swapon -A to activate and -S to status. Now we have two. We have the one we already had and the one you just exposed. If you go to the free, you will see that the swap partition has increased. And now we have two swap partitions. The one we already had and the one we just added. You can add partitions, you can add swap partitions, you can disconnect and power off swap partitions, but I'm not going to cover that on this chapter. That's for a separate video. Like and subscribe to get notified of that. But now we know how to create a new swap partition and extend our swap space. You can create swap files. I will show you how on a separate video, not on the sequence of the RH134. Like and subscribe to get notified of that, and you'll learn all about it. Cool. Now, to wrap things up, because this video, it's already getting a little bit big, which is fine. We're going to create partitions using GPT, the global partition table. But since you're already here on MBR, let me show how to create an extended partition with logical partitions. So I can just go to the fdisk. Now, watch this. If I type N for new partition, it's going to ask me for primary or extended. I can create a fourth primary and I hit my limit. Or I can create an extended partition so I can put logical partitions within it. Okay? So, for example, if I go here, I have my, it's here. So I have primary. This is a swap, right? If I create a primary with 1 GB, then I have space I will not make use of. It's just an example. I'm not limited to 1 GB. This is just an example. What I'm going to do here is I'm going to create an extended partition and create a slice of 1 GB. Then I can further down the line create further slices of 1 GB. Okay. So I'll say E, and now I'll just hit enter. What this did is that I'm using all the remaining space for an extended partition. And don't forget, that we cannot put data into extended partitions. You can just use it extended to create logical partitions, and then you format the logical and put data within it. Now I hit N, and no questions will be asked to me because the only option is to create a logical within the extended. That's that. Now the questions are the same. Start here, make it 1 GB, and there we go. I'm not limited to 1 GB partitions. I'm using 1 GB just to make things smoother and with some standard sizing. But you can do all the sizes you want if there are enough space on your hard drive. All right? Cool. Now, this is my new partition. I'm going to save. Now I will just mkfs -t xfs partition. It's the same thing. Okay? Now I just can create the mkdir thingy-majiggy. mkdir, not this one. mkdir. Let's call this logical 1. Logical 1. Okay, I have it selected so I can paste it. Let's go back to our VI, to the fstab, micros and partitions. Kacham /mnt/logical 1. Okay, XFS. The spacing doesn't really matter, it's just cosmetics. Defaults 00. Mount Marseille. No errors. lsblk. This is not an error, this is just a warning. lsblk. There we go. And so on and so forth. Okay. Now you have something like this here. These are not. I have made an extended one, and I just created one slice of logical, which means I have all this space to create further logical ones. Now, last but not least, let's create a GPT partition table on a different hard drive. I have here a spare one that I'm not using yet. Even though you can convert MBR to GPT and vice versa, they are convertible, but be careful that things may just not occur that well. If you are in a pinch, you can convert, but avoid that. That's my recommendation. Technically possible, but not recommended. By me, by Ozoi Bits. Cool. Now, let's go to edit this as GPT, and in this case, I like to use a tool called gdisk and not fdisk. /dev. And the disk. This is not installed, that's fine. So dnf install gdisk. You know how this works. Let's go try again. No problem. No partition tables. I'm going to print. I have no partitions, no surprises, but it's this very similar tool. New partition. See, there are no primary partitions or extended or logicals. There are just partitions. First sector. I like this one. I want a 1 GB partition. Type, it's the default one, 83. I print, I confirm, I save. Yes. So slightly different, but the same, like in the movie. So lsblk, there we go. This is the partition. What next? We format mkfs minus t xfs /dev prepepew folder mkdir /mnt gpt pt1 because there is no concept of primaries. Then vi etc fstab. And wait, I don't have it copied. This is this one. Cool. There. mnt gpt1 xfs defaults default 00. Whoops. Mount minus a ls. Oh, does not exist. So what did I call it? So I didn't. It's uppercase TPT. That's fine. You saw the error. You saw me troubleshoot it, and just correct it. It's fine. GPT1. Done. lsblk. There it is. Let's just wrap things up. Let's create a swap partition using GPT. So we'll go back to the gdisk. New partition. 2. Start here. Let's put it plus 2G just to be different. The type, we type L. And should be... I know which one it is. I just want you... Okay, it's this one. Print, swap, save, yes, mkswap /dev. Well, let's just copy paste the whole thing. Repel. Okay, okay. We have any warning saying that we cannot expose. I'm glad we did this because this is different, right? We haven't seen very more simpler messages. So as you can see, it's telling you that I cannot access this partition even though it says it's there. But if I check the proc partitions, you don't see the 0 and the 0 and 3. Okay, it's not there. Okay, it's really not there. This new partition 2, it's not there. P2, it's not there. See? Let's try again just to make sure that I'm doing nothing. I forgot the P1, but okay. It's mounted, it's P2. Okay, it's not there. So even though P2 exists, it's not, the kernel is not aware. Okay, so we should see P2 here, which is the one you just created. P2, it's created, but does not exist. Why? Because gdisk was not able to inform the kernel of these changes. That's what he's telling you here. So the safest way to expose this new partition to the kernel, so it shows up here, is to reboot. Reboot is the safest option. Get some time in your day that the reboot is safe to do and do the reboot. Okay? If you are in a pinch like I am right now, I don't really care. I can use this command here, part probe. This will expose the new one to the kernel. So use part probe at your own risk. The reboot is the safest way to expose new partition to the kernel. If they are not exposed immediately by the tool, for example, fdisk or gdisk, if fdisk or gdisk is not able to expose it. So if gdisk or fdisk is not able to immediately expose the partition to the kernel, for example, you do the W option on fdisk or gdisk, you go to the proc partitions file and it's not visible, the partition exists, but the kernel was not made aware of it. So to make things work, the safest way in this situation, or you see this message here, for example. So partition is created, but it's not exposed to the kernel. Okay? It exists, but the kernel does not see it. The safest way is to reboot the server to expose the new partition to the kernel. This is the safest way. Okay? But if you are in the pinch, you are comfortable, it's something that you can survive if something wrong occurs, which is my case. You do parts probe and the partition is forcibly exposed to the kernel. It's usually safe, but do it at your own risk. Now I can format it. And now you know the drill. I'm just going to get this. I'm going to go to my fstab here and get it there. And it's basically the same thing. And swapon minus status to see it's not there. I'll activate status and it's there. See, pretty simple. So MBR GPT, pick your poison. It's all good and dandy. And woo, almost 1 hour video. So, but lots of good information here. Okay, guys, this is all for this chapter. I forget. Chapter 6. Am I wrong? Am I right? I think I'm right. So chapter 6, all about partitions and swap partitions. GPT, fdisk, and all of that good stuff. Whoo! Like and subscribe, it will help. Comment. That also really helps to get these videos out for as many people as possible. For the last time in this video, like and subscribe, it will help. And I'll see you in the next one. Cheers, guys.